So now we're going to continue looking at our patterns from question 1, and we'll try to evaluate powers that have negative exponents. Okay, and so last day we always worked with positive exponents. Today we're going to introduce the idea of negative exponents. So, and we want to express our answer as a whole number or as a fraction. So we don't want to use decimals as our final answer. So we know that 2 to the 0 is equal to 1. In fact, any number to the exponent 0 is equal to 1. But what happens if you do 2 to the negative 1? Okay, well, on my calculator, if I do 2 to the negative 1, I get 0.5. But again, I don't want my final answer to be a decimal. I want it as a fraction. So 0.5 as a fraction is actually 1/2. 2 to the exponent negative 2 is actually 0.25. But as a fraction, it's 1/4. Okay? And 2 to the exponent negative 3 as a fraction is 1/8. So what I notice here is that 3 to the exponent negative 1 is 0.33333, repeating. Well, as a fraction, that's 1/3. 3 to the exponent negative 2 is, as a fraction, 1/9. Okay? And 3 to the exponent negative 3 as a fraction is 1/27. Same thing here. Again, we follow this pattern. What's interesting is we continue to divide by 3 as you go along. Okay, so 1/9 is 3 sections of 1/3. Okay, and so we continue to get smaller and smaller and smaller. Okay, and so 10 to the negative 1 is the same as 1/10. 10 to the negative 2 is 1/100, and 10 to the negative 3 is 1/1000. Okay, and so what you end up seeing is that the denominator, the size of the denominator actually becomes doubled or tripled or increased by a factor of 10. Suffice to say, it's being increased by the size of the base. Okay, so if we want to quickly reflect, what ends up happening is that the how to evaluate. So when we explain how to evaluate a power with a negative exponent, then what we are actually doing is we have our exponent of negative 3, okay, that which equals 1/8. Well, that's very similar to the exponent 2/3, which is 8. Okay, so what ends up happening is that we're flipping the base. Okay, so we're evaluating it and flipping it. So if I write this out, what ends up happening is that we're going to flip the base and make the exponent positive. Okay, so that's equal to 2 to the negative 3. Okay, and so what ends up happening is that you flip the base. Okay, you switch the numerator with the denominator, and then you turn the exponent positive, and that's what gives us the 1/8. So we're going to flip the base. So flip the base and make the exponent positive. Okay, so any base raised to a negative exponent is equal to the flip of the base raised to a positive exponent.